All right, UA4, unknown angles in a triangle. The properties that we're going to learn in this lesson are really going to carry through for the rest of the year. You use them all the time, so pay attention. We're going to start with just how to name a triangle, like kind of the correct way to refer to it. And we're going to say that each vertex, A, B, and C, are going to be labeled with a capital letter, okay, because they represent points. And we're going to use the triangle symbol in each letter to name the triangle. So in this case, this is triangle A, B, C. Okay, it doesn't matter the order. Let me reduce that brightness. Okay. All right, and then we've got the parts of a triangle. Well, I've just extended the lines to kind of separate and so you can see all the different parts. But we have what are called the interior angles, right? The angles that are on the inside of the triangle. That's angles 1, angle 2, and angle 3. And then you have what are the exterior angles, the angles that form a linear pair with each interior. So 1 and 5, 1 and 4. So 4 and 5 are both exterior angles. And they're the exterior angles with angle 1. So we can say for angle 1, the exterior angles are angle 4 and angle 5. For angle 2, the exterior angles are angle 6 and angle 7. And for angle 3, the exterior angles are angle 8 and angle 9. Okay, C is just the name of the point, but you have this angle here. You might be asking, well, what is that? Well, it's just vertical with 2, but there's no special name in reference to the triangle that we give it. Okay, so the interior and its adjacent exterior, that means 3 and 9, they're next to each other. They always form a linear pair. All right, so here's, I would say, the biggest fact that we're going to talk about in this lesson. And we've already kind of discussed it in class. But like, think of this as an auxiliary line above the triangle. Okay, so if that's an auxiliary line above the triangle, and these two lines are parallel, okay, then we know that this angle 4 and this angle 2 are alternate interior and have the same measure. Okay, same for angle 5 and angle 3. They're alternate interior and have the same measure. All right, and then we're left with angle 1 here in the middle. That's on the line and also an interior angle of the triangle. Well, we know that all the angles on a straight line add up to 180 degrees. So 4, 1, and 5 add up to 180. But 4 and 2 are the same measure, and 5 and 3 are the same measure. Therefore, 1, 2, and 3 add up to 180 degrees. And this is just any random triangle, right? There's no measures here. Like, this doesn't say 30 degrees. These are just numbers that represent angles. So this is a fact for all triangles that the sum of the 3 angle measures of any triangle is 180 degrees. All right, so some other terminology with triangles. If we have an isosceles triangle, an isosceles triangle, just a 3-sided polygon. All triangles are 3-sided polygons, but it's a 3-sided polygon in which at least 2 sides are congruent. All right, so we have 2 sides that are congruent. We call those sides the legs in an isosceles triangle because those 2 legs are the same. We call this the vertex angle, the one that's between those 2. And these 2 angles here at the bottom, right, opposite the vertex angle, are called the base angles. Okay, so fact number 2, if 2 sides of a triangle are congruent, then, oh, that should say 2 base angles, but the 2 base angles are congruent. Maybe we should write that in. Okay, if the 2 sides of a triangle are congruent, then the 2 base angles are congruent. Okay, and kind of the converse is true. If the 2 angles of a triangle are congruent, then the opposite sides of those angles are congruent. So if you have a triangle where any two angles are congruent, then the sides opposite those angles are also going to be congruent. Okay, so that's like, maybe we should just put this in here. It's called the base angle theorem. It's often referred to in the textbook. Okay, the base angle theorem. All right, equilateral triangles. Okay, we've got these three facts. If a triangle is equilateral, then it's also equiangular. Okay, equilateral means all three sides. Equiangular means all three angles are equal in measure. Okay, and again, the converse is true. If all three angles of a triangle are congruent, then all three sides are congruent, so it's also equilateral. Okay, and then for all equilateral triangles, right, all their angles are the same measure, and if all the measures of a triangle add up to 180, and all three are the same, then each measure of an equilateral triangle has to be 60 degrees, 180 divided by 3. All right, so we'll do this one. You do that one. If segment AB is congruent to segment BC, all right, we'll label it because that's what it says. If segment AB is congruent to segment BC, then which two angles are congruent, right? So we just have to identify the angles that are opposite this side and this side. So the angle that's opposite side BC is angle A, but angle A is could be referring to three different angles, so we're going to call it BAC. Right, and then the angle opposite side BA, the base angle opposite this side, is this base angle BCA. Okay, and just like with planes and with triangles, you always put the type of thing you're dealing with here. So in this case, we're talking about angles, so make sure you put angle BCA. All right, you do this one, and then we'll move on to the next fact. All right, so this last fact is the triangle exterior angle theorem. Okay, so I'll read it. The measure of each exterior angle, here we see just one, D. The measure of each exterior angle of a triangle equals the sum of the measure of its two remote interior. Okay, so we've already discussed interior angles. That's just all the angles on the inside. The remote interior angles are the angles, the two other angles that don't, are the two angles inside the two interior angles inside the triangle that is not a linear pair with this exterior angle. All right, so we have the exterior angle and the two remote interior. And what this theorem says is that we know that C and D form 180 degrees. Okay, so C and D form 180. Well, we also know that A, B, and C form 180. Well, then it must be true that A and B together combined have the same measure as angle D. All right, so we can write this out, that the measure of angle D is equal to the measure of angle A plus the measure of angle B. Okay, and so let's just write this here. Remote interior angles. And then D is the exterior angle. So again, this exterior angle has the same measure as the sum of the two remote interior. Okay, again, this is going to show up all the time, so you kind of have to be aware that it's there, right? You're going to see a triangle, you're going to see a line that extends past it, right? You always got to be looking for the idea that these two remote are going to be the same as that measure on the outside. Okay, so we'll do an example here. We'll do this one, and you do the next one. This one says find the value of x and the measure of each angle. Okay, so you need to know this property. But we know that these three angles have a sum of 180, and we know that these two angles have a sum of 180. So we can use this triangle exterior angle theorem and say that this exterior angle has the same measure as the sum of these two remote. Okay, so we'll say that 2x plus 4, right, that's one of the remote interior angles, plus 8x plus 1, that's the other remote interior angle, is equal to 11x minus 3, the exterior angle. Right, so we set up an equation that we know to be true. Now we just do some algebra, combine our like terms, and isolate the x. So we've got 10x plus 5 is equal to 11x minus 3. Take 10x from both sides. So 5 is equal to x minus 3. Add 3 to both sides. 8 is the value of x. All right, but we need to go a little bit further, find the measure of each angle. So substitute 8 in for each x. 2h is 16. 16 plus 4 is 20. 8 eighths is 64, plus 1 is 65. Okay, so this happens a lot. This diagram's not drawn to scale, right? That's not a 20-degree angle. Okay, and then lastly, we can substitute x into here. But we already know the answer because it's the sum of these two, right? It's 85 degrees. But we'll substitute 8 in just to make sure that we do end up with 85, right? So 8 times 11 is 88. 88 minus 3 is 85. So it checks out. That has to be the right value of x because the sum of these two is equal to that exterior. All right, so for this last problem, you're going to do, the numbers are a little hard to read, but you're just going to find the measure of each one of these numbered angles, and you can just write them in, and then I'll check that when you come to class. All right, thanks for watching.